Okay, cool. So any other questions on that chapter? Actually, we're about to get into chapter 4. Okay, here we go. Oh. Number 3? 30?
Yeah.
In 3-5? Okay. Oh, I think I know what the trouble is there. We get so stuck on mx plus b. And let me see if this is the trouble. The nice thing with that one is it's already solved for y. The bad thing with that one is it seems to not be mx plus b. I don't know if that was the problem. What's the slope?
2/1. There's no slope.
Careful now. The slope is in front of the x. What's missing is the y-intercept, but it's not really missing.
Just be 0?
It's 0. Cool. So the y-intercept is 0, 0. There's an understood plus 0 there if you want. Right? Understood 1s and understood plus 0s, wherever the hell you want.
So this should end up being a straight line? Or
No, because the slope is going to make it curve.
Yeah.
But it's going to be going through
0, 0.
the origin, so this is one where you're going to have to pick a test point that's not the origin. This might be a good one to do.
Okay.
Because if your line goes through the origin, you can't use it to tell which side of the line to be on. It's on the line. Doesn't make any damn sense. I got to use a point that's on one side or the other.
So if you have an intercept of 0, then it's not another way to think of it.
Alright, that's it. So where's my y-intercept?
0.
0, 0. So that's the only time I really put a point there is if it's actually, that's the y-intercept. That's the point that it goes through. And then from there I go
Up 2/1.
up 2 over 1. Good. And what kind of line will it be?
Straight. Solid one.
Solid is the key I'm looking for. And it doesn't curve, you're right, but it's solid. Solid because I'm allowed to include it like a closed circle. Dash would be like an open circle. Cool. So what point do you want to use?
You do 1, 1.
You could do 1, 1. Could you?
1, 1.
You could, because it's not on the line, but it's a little hard to tell. I'm going to use this one to make I can really tell it's on that side, right? So that's the point. What is that point? What is that point there? 1, 0. 0, 1 would be over there. And that's a valid test point to use also. Your test point can be anything. Anything. It could be the point 3.97, comma 2.4896. I don't ever want it to be that. I want it to be 0, 0, but a stupid line went through 0, 0. So I'm just going to pick the next best one. 1, 0. Or 0, 1. Either one. That's the easiest ones to use. So if I plug 1, 0 into this, what does it become? What's y? 0.
0.
Is 0 less than or equal to twice 1? Is 0 less than or equal to 2? Don't overthink it. Is 0 smaller than 2?
Yeah.
Yes. So which way do I shade?
To the right?
Up or down?
Down?
In the direction of that test point, right? I really want that to make sense. Did this point work? Yeah, so it must be on the side where they all work. Cool. Right, Jets fans, Giants fans, I don't know, whatever makes sense. So this way, I'm going to shade that one. Cool. As an extra little, you could try the point 0, 1, and it shouldn't work. 0, 1, is 1 less than or equal to twice 0? Is 1 less than or equal to 0? No, it doesn't work. Good. It's on the side that's not supposed to work. The not answers. The biggest mistake you make with these problems is overthinking it. Draw the line, make sure it's dotted or solid, test point, shade. You're done. Okay. Yeah, I want to do a little bit out of 4, then we'll take a break. And then we get a little bit further.
So now 4 is gonna be more graphing, but with extra stuff.
Yeah.
Okay.
To start off with, anyway. And real quick, while I'm thinking about it, quiz 2. Say next
Oh, the quiz on test.
Monday.
Oh, wait, so we have a quiz and a check. Oh.
Chapter 3. No, the next test is the 14th, right?
Yeah.
Wait. not
Today is
14.
the
Fifth.
5th.
So a week and a half.
No. So the next test is a week from this Wednesday, right? Okay. So let me do this. Let's make it. I don't want to do that to you.
Yeah.
Let's do Wednesday,
Quiz.
but we'll only go 3-1 through 3-4.
So that's the next class period? Or next
A
class,
week
whatever.
from this next Wednesday. or
No,
Wednesday.
this Wednesday. The next test is when?
A week from Wednesday.
A week from this Wednesday. I like it. I never try to give you a quiz the day before a test, because then I don't have enough time to get it back to you. Right?
Okay.
So our next class we have a quiz.
Yes, cool.
Fine.
So my little check on if you're up on your homework.
Do we don't have to turn it in until the test though, right?
The corrections? No.
No, but the homework? We don't turn
Homework
it
you have
until
until
the
then,
test.
yes.
The
But you
test.
should definitely be a little bit of the ways into chapter 3, if not further.
Well, if you're at 3.4, you
Chapter 2 should be in your rear view mirror at this point. If it's not, then you need to come see me. Yeah. Okay. And this is going to be pretty basic stuff. Nothing too intense. All right. I'm going to lecture a little bit, and then we're going to take a break, and then we're going to come back and I'm going to let you guys do several problems in groups to try to get the idea. This is kind of a nifty idea. If I told you that I'm twice as old as you are, you know how old I am then. I have a clue how old you are. How old are you? 18. Well, let's pretend. I passed that age a little while ago. But let's say that I'm twice as old as you. Now everybody knows I'm 36. Twice as old as 18, right? But if I said, I am, 20 years older than, what's going on? Don't worry, sorry, we're in the same boat. 20 years older than you, Denise. So I'm 20 years older than she is. Do you have any idea how old I am? You're not allowed to talk to Denise. She knows how old I would be. And again, I'm just guessing here, but how many things do you not know in this situation?
How old you are? Well,
So 2 things, right? You don't know how old she is. You don't know how old I am. How many relationships did I give you?
2 very good.
Careful, how many relationships did I give you between us? 1 relationship. It's not
X
enough.
and Y equals.
If I have 2 things I don't know, I need 2 pieces of information to get them. Does that make sense? Sort of like trying to solve a murder. You're always trying to gather more evidence because there's so many things you don't know. You need to have as much evidence to figure out those things you don't know. Are you kind of with me?
Yeah.
So this is a mystery, not a murder mystery. Nobody had to die. But still, we don't know how old either one of us is. So let's say it like this instead. Let's say that our ages add up to be 58. How many answers are there to that one equation I've put up?
A lot.
Infinitely many. So right there, I already know something's wrong. There's only one answer. We each only have one age. I don't suddenly become 72 and then suddenly become 10. I'm one age. So I need one more piece of information. So let's say that the difference in our ages is, let's see, I'm trying to actually come up with something, I don't know, 20. Now, I should be able to figure this out now because I have 2 distinct pieces of information. And what I mean by distinct, if I said I was twice as old as you, and you're like, that's not enough information. I said, okay, well then she's half as old as I am. Did I just give you 2 pieces of information? No, I told you the same damn thing twice. Thanks, Jeff. I still have 2 things I don't know and just 1 piece of information. These are definitely 2 distinct pieces of information. They're not dependent on each other. This is adding them to get something, this is subtracting to get something. So, can you give me like a list of answers for this? What are some answers to this one?
57 plus 1.
Alright, 57 and 1?
20 plus 38.
20 and 38?
30 and 20.
30 and 28, I like it. Right? You with me? Those are answers for that one. What are some answers to this one?
10 and 10.
Careful. 10 minus 10.
30 minus 10.
30 and 10.
40 and 20.
40 and 20.
Wait.
50, 30, I like it. Right? And you can that would be infinitely long. That would be infinitely long. You with me? That kind of sucks. Just
Then you're going to graph two lines and where it intersects.
exactly. So the idea is, since each one of these lines, and you can see it's a line, each of them, have infinitely many answers. If I just graph them, when I graph this line, that's all its answers. When I graph that line, that's all its answers. Where they meet
Is the X and Y?
is going to be the answer for both. Now, one way to get it, though, is to keep going. This one I don't really necessarily want to graph. What I had in mind was this here. 39, 19. And look here. 39, 19. Right? Now, real quick, stay with me. That is one way you could do this, but why would you maybe not want to do this for every problem? Good
And the
Lord,
numbers are
right?
long.
What if the answer was 1.7 comma 3? I don't want it. No, I don't want to do that.
Yeah, I don't want to do that.
I don't want to do that. Good. That's what I want to hear. But you guys with me, though? That is one way to find it, but the quicker way is to graph all the points. You graph the line. Now listen, I don't need to get all the points to graph them all. I just need 2 points. Or I just need the slope and the y-intercept. Graph it, graph the other line, see where they meet. So let me give you something with a little smaller numbers here so we can use it a little bit easier.
That's okay.
That one I wouldn't really want to graph because they meet way out at 39. Let's not do that. That's one we would do with algebra. There's an algebraic way to solve this. We're going to start with a graphical method. Graphical method to solving. And these are called linear systems of equations. Good heavenly Lord. They're called a system because there's more than one. They're called linear because the power I see is a first power. None of them are parabolas. There's no x squares in here. That's what you'll do in later math. You'll talk about intersections of parabolas and stuff. Not here. We're only going to do lines.
There you go.
So, if I add two equations, let's say let me do this. No, that'll be fine. Sorry, let me change it.
-2.
Yep. So make it y equal x minus 4 is one equation. Y equal negative 2x minus 1 is the second. They're definitely not the same line. Do you agree with me? They're not even parallel. I mean, they have different directions. Go ahead and take a minute and graph both of those on the same graph. So graph one, and then on top of that one, graph the other one. See what you see. If you know the algebraic way to do these, don't yet. We're not there yet. Too bad. On a scrap piece of paper, I'd do it if I were you, just to see what the hell the answer's supposed to be. But then you better graph again.
Do you ever add them? Or put them together?
That's what's coming. That's the algebraic way to do it. We're sticking with the visual way to do it for right now.
I think I remember like you added them.
Yes, exactly.
I don't know.
That's the elimination method.
Okay.
Some books call it the addition method.
Is this still involving perpendicular stuff or no? Is this still parallel stuff or is this different?
Well, that'll come in. We'll see. We'll see in a minute how that could come in.
I think it is.
Okay. So on the first one, what's the slope?
One.
Good. 1/1. And the y-intercept? 0, -4. So 0, -4. Now here's my suggestion for this section, because you don't know where they could meet. The answer is going to be where the two lines meet. So I suggest highly that you count further than normal on the slope. So you make sure, if you just kind of draw your line, we tend to not make it straight. Then when you bring the other line, you're like, where the hell are they meeting? I have no freaking idea. So count further than normal. Up 1/1. Up 1/1. Up 1/1. Up 1/1. Okay, that's probably it. I kind of purposely made this one not too evil. So there's one line. There's the first line. Now the second line, what's the y-intercept?
-4.
Careful.
Negative.
-1.
Sorry.
And then the slope tells me to go
Down to.
down to over 1. Sweet.
I went up 2
Rut-row. That would be is negative. Cool. So down to 1, 2 over 1. There it is. So there's my other line. Pretend like it's straight. So if this line is all the answers for this, and this line is all the answers for this, where's the answer that works in both? It's got to be where they meet, because that's the one point that works in both equations, right?
Do we have to shade this at all?
Not yet.
Okay.
You're thinking later.
Okay.
Everybody's always a few sections ahead. So what point is this?
1, -3.
Do not draw this and stop. I need to know what the answer is. You need to actually write out for me what the answer is. The answer is 1, -3. So what kind of thing is the answer to a system of equations always? It is a point. Not a single number, not two separate numbers. The answer is a point.
They're gonna meet there.
Good, because the idea is always where the lines would meet. Sweet. Okay. So let's take a little break, and then we'll try some of these out. Come back at 25. 4:25. What's that?
Getting out early today?
No, at 25. Don't be too optimistic. We will get out a little early, yes. Okay.
Yeah. Well, I've not spent a lot of time with.
Okay.
I would have eaten some.
Thank you.
Thanks, guys. You got it. That's what I was talking about earlier. So it's perfectly fine if you want to do that. I just didn't want to confuse people that
Yesterday.
were never taught
I
this.
loved it yesterday.
But if you do this, I'm
I
fine.
know, I want to go to the beach, but I took a 3-hour nap. I was like, well, I can go.